Okay, so we are going to discuss confidence intervals for population mean in this video. And so how do we construct that confidence interval? We take a simple random sample, okay, and the mean of that sample, mean x bar, is an estimate for the population mean, okay. And if the population has a normal distribution, then we can use z star times population standard deviation over a square root of sample size as the margin of error. All right, and z star will depend on the confidence level. And in case the population may not have normal distribution, we can still use it when the sample size is large. And this is the way we will compute our interval, that we will subtract the margin of error from the estimate, that becomes our lower end point, and add the margin of error to the estimate, and it becomes our upper end point. All right, so this is the way we will create the confidence intervals. And very quickly, let me show you how would you obtain the value of z star for a given confidence level. Okay, so here I'm going to show you that how would you compute the critical z value, z star, for 95% confidence level. And this z star is that specific value of that standard normal distribution. And the way we want that value to be is this, that we would like it to be the value such that the area between z star, positive z star and negative z star, like say this is z star here, okay, all right, and then here we have its negative counterpart, right? Okay, so you have this here, and what we want here is this, that the area in between these two is 0.95. okay, so that's what this value of z star would be. Now see, we are using our graphing calculator that we use in the class. What we need for that is that we need the area to the entire area to the left of this value, because it gives us the percentiles. Okay, so in order to get z star for 95% confidence interval, what I have to do is, first I have to note that this area here is 0.25, right? Because the two tails will share the leftover area. Okay, I'm sorry here, just a second, made a mistake. One moment please. Okay, I meant 0.25, because notice this, 95% of the area is in between these two values, so 5% will be the leftover area. Okay, and from that leftover, 0.025 or 2.5% of the area will be shared by each of these tails, that is 0.025 here, 0.025 here. Okay, so what does it mean? That the area to the left of this z star is how much? It is 0.95 plus 0.025, that is 0.975, right? Or 97.5% area is to the left of this value of z star, for and where z star is a particular z value of the standard normal distribution with the mean 0 and standard deviation 1. Okay, so let's employ our calculator for the purpose. So what we will do is we'll go to this second distribution. And remember this, that if we have a standard normal distribution, then we don't have to enter the mean and standard deviation, because that it takes by default. And how much that value is? Approximately 1.96. So in this case, what happens is that the value that we have for z star, okay, is how much? This is the value of z star for a 95% confidence level, okay. And if you are working with a spreadsheet like Excel, you will go to statistical, all right, and go to normal distribution option. So here we have a standard normal distribution. This gives us the inverse values of a standard normal, right? And by probability, it means which percentile do you want, and it explains it to you here, the value that is asking you for, and that comes out to be the same value, okay. So you can use the similar procedure if you want it for 99% confidence interval or 90% confidence interval, or whatever the desired level is. So for this discussion, we are going to stick to 95% confidence interval, okay. Now, to give an illustration of how these 95% confidence intervals behave, what I'm going to do is that I'm going to create confidence interval for the population mean mu from 1000 simple random samples of size 40 each. And the samples are drawn from this chi-square distribution, which you just saw for distribution of sample means. I'm just going to use the same one, okay. And here I know the population mean is mu, so when I look at those 1000 intervals that I create, that I just want to see that how many of those 1000 are able to successfully capture this mean of 8 units, okay. So let's go to our simulation. And even though a short while ago we had a simulation, but I don't have that file here, so why don't I create a new samples for you? I already have all that entered here. That is, I'm going to create 1000 simple random samples of size how much each? Of size 40 each, and degrees of freedom, which in this case will be the mean is how much? 8, okay. So here we go, we have 1000 samples, and then what we are going to do is that in the cell C41, I'm going to write the means of all those samples, okay. And let me quickly do that for you. So we want the mean, we want the means of who? C1 through C40, and then I want to store it in C41. Here we go. And let's take it to Excel. All right. So here we are. Okay. Let me increase the font size and embolden it so that we can see it a little better. Okay. So here we are. So these are the sample means. Now let's see what the margin of error will be, and margin of error will be the same for each of these because we are using the same sigma and same n, okay. So even though we can do it directly, but just for keeping it slow and a little more easily understandable, let's do this here. Let's just write it in this column. So remember, first we are going to write the z star, and we know how that z star is obtained. We go to norms inverse, right? Okay, and this is 0.975, right? Okay, and then we have multiplied by 4, okay, which was the population standard deviation, and then we divide it by square root of how much? 40, the sample size, right? Everybody clear? Okay, so once we do that, what is the margin of error associated with each of them? 1.2395, etc., etc. So let's just do it for all of these. Okay, so now here we are going to write the lower end point and the upper end points of our confidence intervals by subtracting the margin of error and adding it, right? So here is the lower end of that interval, and how do we obtain it? We just look at the sample mean and subtract the margin of error. So this is the lower end, right? Now we go to the upper end, okay, and where we have what we would do, we'll take the same sample mean and add the margin of error, and then what happens? Here we go. So here are all our intervals. Now notice this. This contains everything from 6.55 to 9.03, and 8 is in there. This interval is 6.07 to 8.55, and what we have is 8 lives in here as well. And among all of these, I don't see any of them yet. You may be able to see, because any interval that has missed the value of 8, oh, right here there is one, right? Here it starts at 8.06, so of course it narrowly missed the value 8, right? Now it will be good if we could do this, that we will go ahead and put them in order. Okay, so what will happen is this, that we shall put them in order according to the lower limit. And let me do this here, sorry about that. Let me increase the font size here also, okay, and embolden it. All right, so what I'm going to do now is that I'm going to put them in order. All right, and we will do this, sort them by the lower end point, okay, from smallest to largest, right? Okay, and there you go. So notice this, that, well, there are lots of intervals that are losers here, okay. So here all of these, they all failed to capture the value 8. And how many of them failed? There are 24 of them, right? So 24 of them have failed on this side to include the mean 8. And let's see what happens on the lower side. Okay, I still don't have very good equipment, so sometimes it doesn't show very well in the final output. So there we are, and we want to say that what is missing the value on this side. Okay, so there we are, right here. Okay, I think I went way too far here. Okay, yeah, this one has kind of just very slightly missed it, right? So how many missed on this side? Notice we are starting at 979 and going through 1001. So how many on this side? 21, then 23 on this side if I added it correctly, right? And 24 had missed on the other side, remember? Let's look at that again. Yes, 24 of them had missed on the other side. So what we saw in our simulation, that 24 plus 23, that is 47 of the 1000 intervals failed to capture the true value 8. So of course 953 succeeded, right? Okay, did capture it, right? Okay, and so you can see the success rate here is 95.3%, and of course we were simulating it from a non-normal distribution, and there are only 1000 samples that we looked at, so it's hard to get exactly 95% rate, but this is what 95% confidence interval means. That is, we are constructing it using a procedure that is successful for about how many? 95% of the times. Okay.